Hi everybody, it's crazy, it's Sunday, and it's time for the UPBGE video of the week. Now before I get started, gotta give a shout out to my trust because you guys rock. To my crazy fam, I love you guys. Now we're up to episode number 136, and today, if I can get it right, we ended off on page 7, which is when to optimize. So, let's get started. When to optimize. Throughout the development process, you will have to make high-level decisions that will affect how the game performs. So it's important to keep performance in mind at all times. On the other hand, doing micro optimizations too early will only slow down your workflow, leading to bugs and sometimes making the game hard to maintain, which is all bad. All right, and what they mean by that is, yeah, you're working on a model and you're boxing it in and you're making it, trying to make it look as realistic as possible. And yeah, you have like a million vertices for one little building. Yeah, that's a little bit too much. So, if you optimize that as you go, you can do it, but if you micro optimize, in other words, you're constantly optimizing throughout your workflow process, you can actually shoot yourself in the foot because now you're changing the geometry of it, and your code work says, okay, you're allowed this much space, and your new optimized thing takes up that much space. So now you've got a problem because now you'll have bugs. That's what they're talking about, okay? And it goes into further. It says, an example of premature optimization is to compress all the textures to get JPEG so that they take up less space. Why is it bad? JPEG is a lossy compression. Every time you open and resave a JPEG file, some data is lost. So by constantly editing a JPEG file, its image quality will decrease considerably. During development, it is always better to save files in lossless formats such as TGA or PNG, which if you've ever played with Blender and you've been in this for a while, if you haven't, description is the book, and make sure you get the files, play around with Blender. Okay, Blender uses PNG more so than JPEG, okay, because it is a lossless. Okay, just to let you know. All right, this applies to audio files as well. Editing should always be done on lossless formats such as WAV. Okay, when you're making a soundbite for your game, make sure while you're editing it, you are saving it as a WAV file, because if you're trying to edit an MP3, which you can if you have Audacity, or Audacity. I don't know how people say it, but I say Audacity because I think it's kind of cool because it's like a little city. But nonetheless, when you're editing an MP3 file, you're losing different things in the file because it's not a lossless file. Now, if you go back to a WAV file and have it open up as a WAV file, you can edit that file, take certain sounds out, save it as an MP3, and it'll work just as good. Now, Blender likes to use MP3 because it's a little bit easier because you got a compression. But while you're making it, have it as a lossless file, whether it be a picture or whether it be sound. You want it to be a lossless file. Okay. Okay. Figure 8.5 shows JPEG compression artifact versus TGA, which compresses lossless. Okay. All right. So that's lossless. And you can see that it's kind of grainy throughout different parts of it, okay? This is lossless, but I'm sorry, I'm pointing at the wrong one. Okay, you can see that the graininess here, the graininess in the background here, but over here, you don't have that. You can actually see the boat here. You will not see the boat here, because there is, I guess, a boat or something there or part of this land that you won't ever see. Okay, this little dock over here, which is very, very, kind of blurry. So you don't want blurry. You don't want loss. Okay, you want lossless. You want to be able to see the detail. You want to keep the detail. And as you make your texture, like this wood texture, you notice that it's got a wood grain. Okay, that wood grain you need to have in, for your bench. This is not a good wood grain look. This would be. Okay. All right, so for the bleh, The Tale of Two Tabs. Let me get rid of that. That's driving me nuts. Okay. For the underwater marine visualization project, Tmfeldman and I were involved with at the University of British Columbia. Uh, uh, I couldn't pronounce his name right, so pardon me if I didn't. If he gets upset with me, please, he can misspell my name anytime he wants. It's very easy to misspell or mispronounce. Okay, so I was given the task to see if you can squeeze more fish into the scene and make it run faster. A typical request from a Monday morning meeting. Because this BGE visualization already contains hundreds of objects in the scene, I just assumed that Blender wasn't good at handling a large number of separate objects. But despite the hunch, which proved to be very wrong, I kept trying different scenarios, turning objects on and off, turning off Python scripts, playing with physics, and culling settings. Then I found a script that, when disabled, would speed up the game performance by 5 times. When 12 PFS, FPS, frames per second, suddenly became 60 frames per second, I knew I had found a proverbial silver bullet. But being the author of the script, I was not convinced that a 70 line that 70 lines, don't need the A in there, could slow down the game by that much. So I dug further until I finally realized that there was an error in the code that made an inner loop run way more than it should. So after 2 hours of profiling, the only finding was a bad nested Python loop. The fix took all of 2 seconds and involved unindentation of the offending code, but the end result was spectacular, to say the least. Silly bugs like this might not be present in your project. Without finding a bug like this, you'll never increase your performance fivefold by fixing a few indentations in the code. But never assume you know where the problem is. Always profile. Okay? So what they're talking about is, you find a bug. It's all about troubleshooting, guys. Yeah, that's troubleshooting your game. You got a problem. The lighting doesn't look right. It may not be the light. It could be your code. It could be something in your code. It could be the object that the light is being cast upon. There's many things that, can change that outlook, can change that view. And what you would want is to go through all of it. Look through, troubleshoot it, okay? Get it back to the spot. Okay, if I shut in on this object, it doesn't do it. If I shut in on this object, it does. So might be that object. So now you're looking at the object. Okay, what's this object doing? Why is it causing this error? I had the same problem happen with some windows. I could not understand why. I mean, I was digging and trying to figure it out, because one window looked perfect, one window did not. And it's right next to each other. And I had to sit there and go through, come to find out that on one set of windows, when I copied them over, okay, had the backface culling turned on. The other window did not. Okay, so it boiled down to, I had backface culling on one, but not the other. And everybody says, well, why don't you just turn backface culling on everything? That's a completely different topic, but I will go into that when we get into backface culling more. But for a short answer, sometimes you want things to work differently for certain other things, and you don't want backface culling on if you're not going to want to see, or if you want to see what's behind it. Like Windows, you want to see what's behind that wall. If you turn backface culling on, okay, it will help that happen. If you turn it off, you won't. Okay, or vice versa. I can't remember exactly how it goes. But, when you want something to do something and you have to turn off backface culling, you're going to need to do it that way. Okay, so with that being said, always troubleshoot your work. Okay, whether it be a little one scene animation all the way up to a full-blown game. Double check your steps. Go back and look. Test things out, push it to the limits. That's what beta testers do. They basically troubleshoot your game for you. That's one reason why a lot of AAA games are failing. They're not getting it to enough people to tear up. I, you know, a buddy of mine made a game and he says, "Hey, play with it." And I was like, "Okay." I got in there and completely destroyed the game. And he got mad at me and he was like, "Why'd you break my game for?" Because if I don't break it, you can't fix it. This is what happened. This is what I did. This is what was the outcome. And of course, he got a little bit more mad at me and then finally realized I was right. You go in there and you completely screw the game up. You make it fail. And then go back and figure out what made it fail. And you can always trace it back to one specific thing, 5 specific things, 100 specific things. And I worked with him, and me and him actually got his game working really good. I didn't know a lot about how he did it. He did it all in Python, but the way his Python was set up, he had it very well optimized. But there was a few problems when it came to collisions and the shape of the mesh, so on and so forth. And believe it or not, he wasn't using Blender. It was all written in Python, and he made his own pictures. He made his own, what they call, I forgot what it was, but, he made his own characters in the game. He made his own backgrounds, everything. He did it all. And looking at it, I pointed some pointers out, said, "Listen, this is one reason why it failed. This is another reason why it failed. This is another reason why it failed. And I did this, and it caused this. And I did this, and it caused that." And then he went in there and he started doing his code thing and he started figuring out that, oh, he forgot a comma here, or the code wasn't reading right halfway through. Or the collisions code said that this was happening. And one of his pictures was not applying right in the code. So on with that is that when you want to optimize your game, give it to people and let them, only trusted people that you trust. I'm not saying just give it to random people you would trust that would keep your game in the background, so that way you can at least bring it out when you bring it out. But people you trust to do some tearing up, to tell them, "Hey, I want you to play this game so hard that it breaks." When I get oops going, I'm going to have beta testers and I'm going to tell them exactly what I'm telling you. Tear it up. Break my game. I want you to make my game fail. I want you to tell me what failed, when it failed, how it failed, and what you think the possible fix is. What would you think it would need to be fixed? And then I'll take it back, redo everything, and send it back to you. Have you to destroy it again. Because that's optimization. It isn't just all about making sure the pixels are on the right spot and your code is perfect. A lot of it also has to do with other people seeing it with a pair of different eyes. Okay? So, all right. So, how to optimize. Keep on going here. Let's see here. Yeah, I'm going to go probably, I'm going to go ahead and do just this last little bit, maybe. Yeah. Performance profile. So, no, I'm going to go ahead and leave it here. We're just going to go ahead and get down to the bottom of how to optimize. How to optimize is going to be a little bit better story. It does have more space. You know what? We're going to go ahead and do it. Yeah. All right. So let's do it. Let's do this. Let's make this a little bit longer episode. All right. So as obvious as it sounds, the first step in optimization is locating the bottleneck. A bottleneck is the point in the game where it is taking the longest time to compute. Focusing on the bottleneck will make sure that your work the work you do in optimizing the game will have the largest impact on performance. Common wisdom in the programming world says never assume you know where the bottleneck is. Experience might tell you where the slowdown should be, but if there is an unexpected bug somewhere, the bottleneck might not be where you think it is. Always make sure that you locate the bottleneck before trying to remove it. The performance profiler in Blender can give you some very insightful information about the performance of the game and where the bottleneck might be. Okay, so the performance profile in Blender. Blender has a basic performance profile available to you. It gives you timing information on how long a frame takes to update. as well as the breakdown of how long the game engine spent on specific tasks. Turn it on, go to the render properties editor, and check frame rate and profiler under performance as shown in figure 6. So this is going to be different if I switch over to here. Okay, this is the last one we worked on. If you go into, we'll have to get to a different one. Let's change this from that to properties so that way you can see it properly. Okay, and of course up here we're going to stretch that out so you can see it better. All right, so I don't see performance in this. This is different than what it used to be. But when you put on debug, you can put on properties, physics visualizations, which will kind of help you do it. But it's usually under shading. So let's see, probably in here maybe. Navigation. I don't know exactly where it is. If you know where it's at, then you can follow along with the book. I don't see where I have it. Nope. That has nothing to do with it. Because shading is different, okay, because you got shading here, which shows you all your tone, but then you got system, and it does not have performance, because UPBGE took performance out, I do believe, because it just doesn't work. Okay, so it doesn't have it, unfortunately. I figured it would, because most things need it. Unit auto. Python console. You can actually, that right there will help you out as the Python console when you're looking for problems. That's physics and all that. World won't have it. Missed. Yeah. So unless it is under display or your objects, no. Okay, so it should be under here, but it's not. Okay, so but UPBGE changed a lot of things, and I'm working from 0.2.0. It's probably an automatic thing now. If we look at, and I'm going to go ahead and bring up regular 2.7b. Okay. Yep, y'all remember this one. Okay, they did not optimize this. Okay, this is not an optimized one. Okay, you should be able to see it in here. You got performance, which is right here. Okay, it's not in UPBGE. I don't know why. I have to ask one of the people that I over in the UPBGE server on Discord and ask them about it. But this is it right here. This is your performance. It's actually a lot different than the book, which is this. Okay, which you got debug properties, frame rate, and profile, physics visualization, all frames, display list, and depreciation warnings. Okay, on this one, you know, performance has auto detect, fixed, you know, you have save buffers for memory, all kinds of neat stuff, tile size. You know, it doesn't even have any of this because you don't really need it. What this is referring to, I think, is basically, what's that? I just had it just a minute ago. Yeah, it should be in your debug profile. Okay, so your debug properties, you can see your frame rate, you can see your render queues, yeah, queries, you can see your properties, which in a lot of this is there. You can get your depreciation warnings and all that other stuff, and that actually pops up, and I'm gonna bring it up if I can find it. Yeah, there it is. Okay, that's right here. It's gonna put it to right here every time. When you bring this up, do not hit close. Hit minimize. Because if you hit close, it's going to close it out. Now I'm going to do it on the other one to show you. Okay. I believe I said this before. Okay, this is 2.79b. So if I hit close, guess what's going to happen? Okay, down here, it just showed that it closed. Okay, I do not have it anymore in here, see? Because if you hit X, it closes out of it. So you don't want to do that, okay? But most of that is found in your debug properties, okay? Okay, so the profile can also be accessed from the top menu under Game. So you can actually go under Game, okay? And let's see, you can show render queries, frame rate, profile, frame rate, and profile right here. Okay, you can do it there as well. Okay, so if you don't feel like going through all the extra steps down here by clicking on that for debug properties, you know, I usually just hit properties. You know, frame rate and profile can work, but sometimes it don't. All right, so once that's enabled, you will set a text overlay as depicted in 8-7 in the top left corner when running the game. Okay, so you'll see this, and a lot of y'all see this, okay? Whenever you're running a game, and I'm going to go ahead and hit up here, bring it back up here. I'm going to do the standalone player because UPBGE, now you see it all right here, okay? It's right there. From here to the left, I can't get on there, but it makes it work, okay? And I don't know why that's doing that. Sorry about the blank screen there for a second. Devices, it's going to do it one more time. Pause. Sorry about that. My Windows is trying to be funny on me today, but this is what it does, okay? And it adds this to your screen, okay? All right, so the profile, the most common measurement of performance for a real-time application is frames per second. That's how many images the computer can render per second. This number is shown at the very top of the profiler in two ways, okay? Which is your frame rate, which would be right there, okay? It shows it in milliseconds and frames per second. Okay, first is swap, okay? Which refers to the time it takes to swap out the previous frame for the new one expressed in milliseconds. Secondly, as a more readable frames per second value expressed as hertz. So the first one there is going to be in milliseconds. It tells you how fast it swaps out. So it takes about 6.67 milliseconds for it to switch between each frame. Okay, so that's basically 60 frames per second. Okay. All right, so moving down, you can see the number in the first column is the time it took to complete the operation in milliseconds. The second column is the same value expressed as the percentage of the total time. Okay, so that one's saying which one? Mine ain't time, it's actually physics. Okay, of course, in theirs, it's different. No, it's physics, yeah. Okay, so, it's how long the physics takes to load, which you see that mine is 0.6, no, 0.00. So it doesn't really matter because it's so fast. Well, I've got a very fast GPU, so that makes sense. Okay, to understand the profile, simply look at the relative percentage of time it takes to complete all the operations. The table below shows you the meaning of each. Okay, so the frame time, okay, that's the first one here. Okay, combined time, entire system, 100% typical ratio. Okay, your physics is bullet physics times CPU 10%. Okay, well, theirs is 10%. Mine is 0%. Yep. Okay, so, and then your logic, which is next down below from that, let me get my little cursor to point at it there. Okay, is game logic time, which is CPU, which is 5%. Now, a lot of it goes through GPU, so, but they're saying that most of it's ran through your GPU or CPU. So it depends on what you've got. Okay, and your animation is animation time, your CPU, which is 5% ratio. Okay, your network, I think it's network. Yeah, network. Okay, network time, network, and 0% because you're not playing online. Okay, and then your scene graph, which is scene setup time, CPU at 10%. Okay, and then you've got your rasterizer, which is rendering time, which runs through your graphic card, which is 65%. So the more that rasterizer goes up, the more it's bottlenecking on your computer because you're forcing everything to the GPU. Okay, and then your services, which is miscellaneous time, CPU, which is 2%. Let me scroll down over here. Okay, and then get that line up. Okay, and then your overhead, which is miscellaneous time, CPU, which is 2%. And then your outside, okay, which is idle time, which is CPU, which is 0%. Okay, and then there's other ones on there. There's GPU latency, and also I've got debug properties, which shows you the cylinder moving at a certain speed or at a certain location on the screen. You can do that. Okay, it is possible to say that, say what would be an ideal profiler time ratio. The typical ratio is only meant to give you a very rough idea of how an average game will perform. Each application is different. A fast action game with lots of physics could easily spend 25% of the time on physics. A graphics intense cutscene might spend 95% of the time on the rasterizer, while a specific visualization might use 40% of the time on logic. Okay? The outside time deserves special attention. This time represents the idle time that is not spent actively doing anything. So do not be alarmed if the outside value is too high, especially when the frame rate is capped at 60. So what it's telling you is this time, which one was it? The outside, okay. So this one right here, if it's high, don't worry about it. Okay, that's just time that it idles. That means that, it's not going to hurt anything, especially if you're capped at 60 frames per second, which this one is. Okay, most of it is capped at 60 frames per second. All right. Furthermore, the ratios change depending on the computer hardware. For example, a computer with a fast graphics card would breeze through the rendering in almost no time, making the rasterizer time ratio much smaller. As you see with mine, my rasterizer time is 0.06 seconds. Okay, that's fast for raster time. Okay, I do have a good GPU. All right, making the rasterizer time very small. Because of this, the profiler works best when it is run on a computer with hardware that matches the intended target audience. Otherwise, it might give you a false sense of where the bottleneck is, okay? So, being that I've got a fast computer, that could mess it up. So you want to have like an older computer that you can test it on. I've got a very old computer. We call it my potato, because yeah, it can't handle a lot of the games that I would like to play on it. It's very old. All right, so for a detailed analysis of what each of the components do, Mitchell Strokes has written a very comprehensive article on this subject. It can be found at wikiblender.org, and then I'll switch over here if you want to see. Yeah. Okay, so if you want to write that down or pause the video real quick so you can copy that down. If you have the book, all you got to do is click on it. I do not have internet on my computer right now because I've got it shut off. So you will, if I click this, it's going to take me to a blank page. It's going to say there's a 404 error. But you click on it and it will take you to that website. Okay. So that's where we're going to end this week, is at the bottom of page 11. And we'll start next week on quick and dirty optimization techniques. Let me go ahead and close out of that. Okay, and let me switch. No, I don't want that one. Switch back to there. There we go. Okay, so quick and dirty optimization techniques next week. Okay, page number 11. See you then.